Friedrich from Dresden publishes these directions and speeds. So basically, this was one starting point for our measurement. It was performed on the stage one geodetic point of high class, which had been established during this international GIANT project, so Geodetic Infrastructure for Antarctica. This is a SCAR project. It's finished now, but the result is creation of a lot of points in different bases. So static GNSS observations were performed in the polar season 2012-2013, and comparison between 1998, which is the year of establishment of the first point, which was the only previous measurement on this point, and the current one. Nearby permanent GNSS stations were used in order to evaluate this Koch-1, as you see here. This is Kliment Ochrydzki, the name of our station, Kliment Ochrydzki 1. So this station its precise coordinates were determined using stations on different tectonic plates. You can see the tectonic boundaries here. Coordinates were achieved in two epochs, 1998 and 2012. And the result, there were some residuals. Basically, the results are these. So, according to the Nouvel 1A tectonic model, the speed is normal, so it's 0.30 centimeters. So 22 millimeters per year. I'm sorry, here is written in Bulgarian, but 22 millimeters per year in this direction. And when we remove the model, the speed and direction of the models, another 9 millimeters per year is are observed in this direction. This is due to the rift in the Bransfield Strait, probably. Yeah, the results were compared with the main speed and direction are similar with the Nouvel 1, but there is another 12 millimeters which can be evaluated more in the future. Third one, ionospheric research. So this is in the environment part, I think. 2013 is was the solar maximum year. So this is part of the 11-year cycle of the sun. So we are here. The cycle is still going on. It depends on the number of the sunspots.
Sorry.
Sorry.
You've run out of time.
Okay, so
quickly wrap up and.
Yeah, then some results were achieved. Ionospheric maps. They were compared with maps created by NASA of the ionosphere over Livingston Island. So future perspectives, a new geodetic point of high class is needed because the current one is in not very good position. Some new GNSS Galileo system is good to be evaluated in the area. More glacier research, more ionospheric research, and I am presenting. You can see more stuff on this movie. This is GNSS observations in Antarctica. Is uploaded in Vimeo. It has English subtitles as well. So on behalf of APECS Bulgaria, I thank you for listening to me, and I hope some of you we are going to see each other in Sofia on the APECS World Summit. So thank you.
Okay, thank you very much. If there are questions, save them, and we might have a chance to ask them later. And if not, okay, all this will be online, so you can email Asparu directly. So now we're going to hand over to Kristina Kotsiol from Gdansk University. and she's going to talk about persistent organic pollutants released from a glacier in the context of changing melt and snowfall.
Hello, everyone.
Hello, we can't see your screen. There we go. That's good.
Okay, great. This short talk is just going to present preliminary results from a persistent organic pollutant study on an Arctic glacier. So we go all the way around the world. But persistent organic pollutants have been also shown or suggested to be a problem in the Antarctic, influencing penguin health. So it can be interesting for all the Arctic and Antarctic scientists. Why do we study them? Well, first of all, to those who haven't heard about persistent organic pollutants, it's those types of pollutants which have a really long lifetime in the environment. So it's hard to decompose them. They will stay in the ecosystem for a long time. And glaciers have been shown to store organic matter recently. And as such, they can also accumulate pollutants and become secondary sources of those to rivers, to ecosystems. So in this study, the aim was to look at their short-term dynamics during a melt season on a particular glacier. And this glacier was Foxfunna, located in Svalbard in the Norwegian Arctic. Svalbard is a coal mining area, so there may be local sources of pollutants, as well as long-distance sources from Europe. The setup was really simple. Sampling per glacier rivers in a time span to see what happens, how quickly the pollutants are released. The main sampling site was collecting all water from the glacier and the icing in front of it, which usually is a frozen outflow from the glacier. I can go into a bit more detail if needs be in the questions part about this particular icing. But just to distinguish whether the glaciers now contributes the same way as that main sampling site to pollutant release, there were some additional sites sampled for short